Today is the day I've been so excited to get to. Trigonometric identity proofs. Day 5. Last full day. After this is practice test and test day, kids. This is amazing. It's cool. And it's fun. Now, I think it is. But I also drink Dunkin' Donuts coffee. And when you drink Dunkin' Donuts coffee, you also think trigonometric identity proofs are fun. Ooh, that's hot. Anyway, let's get started. You have to remember things. We talked about this yesterday. That tangent is sine x over cosine x. Cotangent is cosine x over sine x. You should actually be pausing this and doing this on your own. So pause it now. I'll give you a good face. Oh, welcome back. Thank you. Cosecant is 1 over, hope you enjoy that face, 1 over sine x. Secant is 1 over cosine x. Here's a huge one. Here's a big one. Sine x plus cosine x equals 1. Tangent squared x plus 1 equals secant squared x. And cotangent squared x plus 1 equals cosecant squared x. Get them down. Get them memorized. I don't know how much I got to tell you guys. This is just stuff you got to start committing to memory. All right. How to write an identity proof. Now, these aren't like what you did last year in geometry. That's not that. I don't even think it's that difficult. It's just like a little bit of a puzzle. It's a little bit of a, what can I do? What can I change? How can I modify things? Your goal is to get both sides to look the same. You have to leave one side alone, manipulate one side. And that one side is usually the more complicated. More complicated. Keep trying until you find something that works. It's called perseverance. Here is the Webster's Dictionary for perseverance. Let me read it to you. It is to continue in a course of action even in the face of difficulty or with little or no prospect of success. That's called perseverance. I will tell you right now, those people that have perseverance in life will be incredibly successful. If you do not have perseverance, if you have head in the sand, get butt kicked personality, life is going to be very difficult. But if you have perseverance, you're going to be okay. So let's see if we can persevere through some of these. Right now, my goal is to make one of these sides look like the other. So I'm going to look at it. I'm going to say, okay, which one of you sides is more difficult or more complicated? Well, clearly, this side is more complicated. So we're going to work on that side. We're going to try to see if we can get it to look like cosine. We're starting easy, kids. It's going to get a little more complicated. It's going to get a little more crazy. Stay with me. There's nothing you can do with sine. Nothing. Sine is sine. I never said to you, sine is the inverse reciprocal of the quantum physics of cosecant. No, it's just sine. But I can do something with cotangent. So I'm going to rewrite this as sine. And a lot of what we're going to do is fractions. So you might as well write it as a fraction. Sine of x over 1 times cosine x over 1. Does it equal cosine x? Just keep the second kind. This side, don't touch. Can't touch this. Can't touch this. I have to listen to that tomorrow. All right. Oh, cosine x over cotangent x is cosine x over sine x. Well, if I take my purple pen out, I can cancel that sine x. And look what I end up with. Cosine x equals cosine x. That's all there is to it, Kraus. You've been making this sound so hard. Oh, It will get a little more difficult. Oh, yeah, buddy. Gonna need some coffee for the double fractions coming. Thank you, Dunkin' Donuts. I love you too. Yep, they're a sponsor. Haven't given them anything yet, but they're a sponsor. So, this is the more complicated side. We're going to work with that side and that side only. We're not going to touch the other side. Okay? We're going to see if we can get it to be cotangent x. Now, if I'm thinking about it, really what I need to end up with on the left side is cotangent x is really cosine over sine. So if I end up with something that looks like cosine over sine on the left side, I'm pretty good. So, let's see. Cosecant is 1 over sine. And secant is 1 over cosine x. Now, I've told you a million times, I've been trying to get you ready for this. Dividing by a fraction is the same as multiplying by the reciprocal. So really what I'm going to do is I'm going to take 1 over sine x. This is going to come up here. I'm going to multiply by it, but I got to multiply by the reciprocal, cosine x over 1. Does it equal cotangent x? Well, if I multiply across the top, I get cosine x over sine x. Now, you can't stop here, even though, duh, cosine x over sine x. You have to finish and say, okay, cotangent x equals cotangent x. Ka-ching. All right, moving on. Wait, I can only do a certain amount. Otherwise, I got to stop. Hold on. Let me see how much I've done. Yep, got to stop. Bye. I'll be right back. I was just thinking every one of these videos, I needed a shave. Try this one on your own. Hit pause. I'll give you another good face. Hey, you're back. Oh, my God. That was so much fun. If you didn't hit pause, shame on you. Okay, all you're doing is watching a trained monkey work. You need to try these on your own. You need to fail. You need to try. You need to fail. You need to try. You need to be successful. That's how it works. That's how life is, okay? You try, and you try, and you try, and you try, and you try. Everybody that thinks life is easy is, well, I wish I could say it nicely, but they're morons, okay? Life's not easy. If life was easy, everybody would be rich and everybody would be happy. It's not easy. You have to work for it. Then you're happy, okay? So, here we go. Hopefully you've paused it now and you've come back. If you haven't, rewind, pause, come back. All right, here we go. Secant is 1 over cosine x. Clearly, we're working on this side. It's the more complicated side. Times sine x over 1. Does it equal tangent x? Well, this is sine x over cosine x. Does that equal tangent x? And then your last statement has to say, okay, I know that sine over cosine is tangent x equals tangent x. See, I told you could do that one. That one wasn't bad. All right, let's try this sucker. Clearly, we work on the left side. Now, there's nothing to do with cosine, but let's see what we got. So, cotangent is cosine. We need more room, I think, on this one. Cotangent is cosine x over sine x. Oh, this one's about to get real, kids. All over cosine x. And I'm going to put it over 1 because I know that I'm going to end up flipping and multiplying. Even though it doesn't look like I have a fraction on the bottom, I'm going to make it a fraction. So we're going to flip and multiply. So we're going to take cosine x over sine x, and we're going to multiply by the reciprocal of that. Oh, no, this one's not bad. 1 over cosine x. I thought this was going to get hard. It gets hard when you start getting the squareds. When we start getting the squareds in there, it's going to start getting hard. And then these cosine x's cancel, and it leaves me 1 over sine x equals cosecant x. And then I know that is cosecant x. So cosecant x equals cosecant x. Proof. Left side's more complicated. Pause it. Try it on your own. Come back. Welcome back. All right. So we don't have any squared yet, so this one's not bad. So this is just cosine. Again, almost all of this is going to be done using fractions. Over 1 times 1 over sine x. Does that equal cotangent x? Of course. This is cosine x over sine x. And I get cosine or cotangent x equals cotangent x. Uh-oh, we got a squared. By the way, you're not allowed to divide and start thinking you can divide things. This is the more complicated side, so now I'm working with the right side. Cotangent squared x. Now, I'm going to start, I don't know, there's a way I can start and not get it right. Like, don't I have something for cotangent squared x? Let me see what I have up here. It's right here, kids. Oh, I don't have it exactly, do I? So, let's see. I could subtract 1 and subtract 1, and I could say cotangent squared x is equal to cosecant squared x minus 1. That seems to make things more complicated, though, so I'm not sure I want to use that. Another thing I could do with cotangent squared, let's see if I got, let's try this. Cotangent x is equal to, isn't cotangent really just cosine over sine? So let's see if I can do that. Let's see if this works. Cosine squared x over sine squared x times, now what's tangent? Tangent's sine x over cosine x. Well, wait a second, that's not bad. That means that this sine x cancels with one of these, and this cosine x cancels with one of these, and then that leaves me on the left still cotangent x, but on the right I just left with cosine over sine, which is cotangent x. Got lucky. All right. Sometimes you get lucky, sometimes you don't. All right, left side's more complicated. You should be able to do this one. Do it on your own. Pause it. And you're back. Gotta love the faces. The faces make doing it on your own so much more fun. You look up and you laugh at me. You're like, oh, Mr. Cross, you're a silly guy. All right, let's work. This is an easy one. This one is sine x over cosine x times cosine x over 1. Ka-ching, ka-ching, sine x equals sine x. Like it really doesn't even get any easier than that, chillin'. It's going to get hard. Oh, no. What do we got here? So I could replace, so I have two options for replacing cosecant x. I could replace cosecant x. I could replace cosecant x. Oh, wait, hold on. Gotta go. I'll be back. Oh, all right, here we go. Okay, so what I was saying was I can replace cosecant squared x with two things. Cotangent squared x plus 1, or I can replace cosecant squared x with 1 over sine squared x. Now, I'm going to start with the simpler case. If it doesn't work, I go to the more complex case. It's all about perseverance, kids. So let's try this. This is just sine x over 1 times, I'm going to start with this one. Let's see if this works. 1 over sine squared x. Does it equal cosecant x? Well, I can come through and I can say that sine x cancels with one of those. And what is 1 over sine? It's cosecant x, and that equals cosecant x. Now, I'm just curious, what would happen, and this is just me going on a side, because I'm not even sure if this is going to work. What would happen if I replaced it with this crazy one? So I did sine x times cotangent squared x plus 1. Does that equal cosecant x? I don't know. Let's see. I can distribute, and I would get sine x cotangent squared x plus sine x equals cosecant x. Notice how it's gotten worse, not even better, but let's just see. And cotangent squared, so this is really sine x over 1 times cosine squared x over sine squared x, and then plus sine x equals cosecant x, and then this cancels with one of these, and it leaves me cosine squared x over sine x plus sine x. I'm just going to put over 1. Does it equal cosecant x? Now, in order to add these, they have to have a common denominator. So my common denominator is sine x. This one doesn't need to change. It's just cosine squared x. This one, if I multiply the denominator by sine x, I got to multiply the numerator by sine x. So then I get sine squared x. Now let me bring this up here. So now I have cosine squared x over sine x plus sine squared x over sine x. Does that equal cosecant x? So now I can combine these because they have a common denominator. So sine x, and the numerator is cosine squared x plus sine squared x. Does that equal cosecant x? Well, if you remember, this is one of my trig identities. I know that cosine squared x plus sine squared x is really just 1. So this becomes 1 over sine x equals cosecant x. And then that is cosecant x equals cosecant x. So you can get there, but that one took 1, 2, 3, 4, 5, 6, 7, 8, 9 steps. And I think the other way took like 2. So yeah, sometimes you'll start and you'll go the wrong way, and you have to be perseverant, and you have to be okay with things. So what do we have here? What is this? This is really secant squared x minus 1 over, and I'm going to rewrite that as cosine squared x over sine squared x. This is now, if in the numerator, if I'd written it like this, I have a really, in the numerator, I write it as 1 over 1. I am going to take, just on the second one, first one I'm just going to leave as secant squared minus. I'm going to multiply by the reciprocal. I'm going to do it right here because I'm running out of room. So that's sine squared x over cosine squared x. Oh, looks like if I had left it the same, I would have been all right. So this is sine squared x over cosine squared x. But that's really just tangent squared x. So this is secant squared x minus tangent squared x. Does that equal 1? Well, if I remember correctly, secant squared x, this can get replaced with tangent squared x plus 1 is really secant squared x minus tangent squared x. Does that equal 1? Well, these cancel, and I get 1 equals 1. I wonder if there's an easier way to do that one. Let me take it back slightly. Let's see if I have time. Nope. I'll be back. So there is a slightly easier way to do this one. Slightly easier way. So I knew this. I should have just said. I said I knew this is cosine squared x over sine squared x. So if I do that and I say, okay, now I'm going to multiply by the reciprocal, sine squared x over cosine squared x. I can get 1 over cosine squared x minus sine squared x over cosine squared x. And then since I have a common denominator, it's really 1 minus sine squared x over cosine squared x. Does that equal 1? Does that equal 1? And if you remember correctly, 1 minus sine squared x is really cosine squared x. So it's really cosine squared x over cosine squared x equals 1. And clearly there you have a 1. I wonder which way I did on my notes. Oh, so that's the way I did it. I did on my notes that way. A couple different ways of doing that problem. All right, let's go over to whatever's next. 10. All right, so it looks like the left side is much more complicated than the right side. Just kidding. JK, LOL, MOMMY. Always don't forget about mommy. Oh, we're not messing with that side. We're going to mess with this side. So this is just cotangent squared x. Now this one's, I'm going to double distribute. You should recognize these are conjugates. So I only have to multiply these. I get cosecant squared x minus 1. Well, I don't necessarily have a replacement for cosecant squared x. Well, I know cosecant squared x is equal to cotangent squared x plus 1. That's what this is equal to. And then minus 1, and then these cancel, and I'm done. That's it. That's all she wrote. That's a simple one. All right, so not allowed to mess with a side. This side's much. This side's easier, so we're going to leave this side. This is the side we're going to work with. So I'm going to leave this as 1 over secant squared x equals. So in order to combine these, they have to have a common denominator. Well, that common denominator, well, hold on a second. Isn't this really just 1 over sine x, sine squared x? So multiply by the reciprocal, that would be sine squared x over 1. So I get 1 minus sine squared x. So this is 1 over secant squared x is equal to 1 minus sine squared x is cosine squared x. I'm trying to figure out how I want to finish this. Because these are equivalent, because 1 over this, I mean, if I change this to 1 over cosine squared x, multiplied by the reciprocal, I would have cosine squared x equals cosine squared x. But that's tough. Let me start over. Let me try it again. Gotta love pencil, right? Let's try this. I don't like messing with both sides. I'm going to make this as cosecant squared x over cosecant squared x minus 1 over cosecant squared x. So 1 over secant squared x. Does that equal? So this gives me cosecant squared x minus 1 over cosecant squared x. So 1 over secant squared x is equal to, now cosecant squared x is really equal to cotangent squared plus 1. So cotangent squared x plus 1 minus 1 all over cosecant squared x. Almost there, kids. So these cancel. And I'm going to rewrite cosecant squared x. So this is really, the numerator is really cosine squared x over sine squared x all over 1 over sine squared x. So what we're going to do now is we're going to flip and multiply. And you're going to multiply by sine squared x over 1, and I get cosine squared x is equal to 1 over secant squared x. So anyway, they're equal. That one's I'm going to have to check out later. See what I want to do with that one in class, actually. All right, I'll be back. And when I get to this problem, you're like, well, what the heck? All right, it could be x. It could be theta. This is the Greek letter, beta. I can put anything I want there. A lot of times we use Greek letters because it makes us look better. Anyway, this isn't too bad. So we got cosine squared beta times, now cotangent squared beta plus 1. Isn't that really just cosecant squared beta? And then isn't this really just cosine squared beta times 1 over sine squared beta? And then doesn't that just give me cosine squared beta over sine squared beta equals cotangent squared beta? And I end up with cotangent squared beta equals cotangent squared beta. See, if you don't know what to replace things with, the problems become very difficult. If you can remember what to replace things with, they're not that bad. All right, next page, last page. Ooh. This looks complicated. I can't really replace sine and cosine. Let me just distribute. Again, I'm not really sure. I haven't done these problems in a while. My notes from last year. So I'm just gonna distribute. So I end up with secant theta times sine of theta plus secant theta times cosine theta. Does that equal tangent theta plus 1? So I know secant theta is 1 over cosine theta times sine theta over 1 plus 1 over cosine theta times cosine theta over 1. It's looking promising. Well, this gives me sine theta over cosine theta. When I multiply numerators, multiply denominators, this one gives me cosine theta over cosine theta. Does that equal tangent theta plus 1? Well, what is sine theta over cosine theta? That's tangent theta. Plus cosine over cosine is 1. Of course, there it is. Tangent theta plus 1. All right, I'll be back. I don't know why I stopped there. Oh, is this the Greek letter psi? I don't remember. Let's see. So we have our choices here. Normally the left side looks a little more complicated. I'm going to do the left side. So the left side, because the numerator is like this, I'm going to break up that. I'm going to make it sine of... Whew. All right, let's go back to theta. We'll pretend we're all theta. I guess I'm not going to put any artwork on there because clearly I can't do that. So we'll just pretend like they're theta. So this would be sine theta over cosine theta minus 1 over cosine theta. Now notice, If these were the same, so you have a common denominator, I can just add them up and put them together to make that. That's right. This would turn into this because they have a common denominator. Does that equal tangent theta minus secant theta? Well, this is tangent theta minus, and this is secant theta. So clearly that equals tangent theta minus secant theta. Now, having said that, let's see if I can work with the other side. So let's work with this side. This would be sine theta over cosine theta minus 1 over cosine theta. They already have a common denominator, so that would be sine theta minus 1 over cosine theta. Oh, man. Either way, it's simple. That was an easy one, kids. All right. Boom. Chaka-laka-laka-la. All right, what we got here? The heck are these things? So these are your formula sheet identities. So these come off your formula sheet. So what I want you to look at is, does this look like something on your formula sheet? And if you come over to your formula sheet and you say, okay, I need 2, what does it say? 2 and sine something and cosine something. 2 and sine something, cosine something. Doesn't that look like this function right here? 2 sine of some angle, cosine of that exact same angle, and that's of course what I have here. So this is really equal to the sine of 2a. Well, what is a? What is my angle? My a is this. So that is what goes in for a. So this is really the sine of 2 times 9x, which is really the sine of 18x. Done. Now I need something that looks like 2 cosine squared of an angle minus 1. So I go over my formula sheet and I say, okay, 2 cosine squared of some angle minus 1. There it is. That's cosine 2a. So this is really cosine of 2a, where this is my angle. So it's really the cosine of 2 times 4x, which is really the cosine of 8x. Now I need cosine squared minus sine squared of some angle. And I think that's this one right here. We haven't used it ever, but that's really cosine 2a as well. That's the weird case I said you probably would never use, but here we go. So this is really the cosine of 2 times a, where this is a, 3x. So this is really the cosine of 6x. Almost done. I'm going to stop here because I got 3 left problems and I can do those at the end. I'll be right back. So it really doesn't matter which one you start with, because both these sides are kind of complicated. So you just got to start with one side. I can start with this side, or I can start with this side. Maybe what I want to do is do both sides. But anyway, I'm not going to mess with the left side. So 1 minus 2 sine squared x. 2's cosine squared x minus 1. That sounds familiar. It's probably up here someplace. 2 cosine squared x minus 1. Isn't that this? Isn't it really the cosine of 2a? So I come back. Oops. Don't want to look at that. Come back here. This is really equal to the cosine of 2a. But I wonder if I can transform the cosine of 2a to make it look like that left side. And isn't the cosine of 2a also this? 1 minus 2 sine squared a. So this would be 1. Oh, I should have used x here. 1 minus sine squared x. And there we go. Done. We can do the same thing here. This is really just the cosine of 2x. And then this can be rewritten as cosine squared x minus sine squared x, and it equals cosine squared x minus sine squared x. You can rewrite it like that. Whatever. Last one. Transform cosine squared minus sine squared x into an equivalent expression in terms of the trigonometric function sine. Well, this is really simple. This is really equal to cosine of 2x. And then the cosine of 2x can be rewritten as 1 minus sine squared x. Oh, actually, 1 minus 2. Why is it doing that? 1 minus 2. Sorry. It'll come back in a second. That'll go away in a second. So, cosine squared x is 1 minus 2 sine squared x. I just screwed that up myself. This is equal to 1 minus 2 sine squared x. All right, kids. That's it. I know it sounds crazy. Hopefully you're getting confident with all this trig stuff, because that's it. That's the end of trig. We have a review and a test next, and that's it. All right. It's been fun. It's been real. And it's been a little bit real fun. Bye, trig. It's been fun. Hit my subscribe button, hit the like button, and tell me how much you love math class. Goodbye.